guys, today we're going to learn how to write the formulas and the names of ionic compounds. It's kind of a tricky topic, isn't it?
It can be, but we're going to do our best to try and help you through it.
Now, first off, we have to understand the definition of something called a cation and an anion. So a cation is what?
A cation is an atom that has a positive charge. So anytime that we have a cation, it has a positive
Now,
charge.
when you write a cation, Mr. Dimitrievich, you have to there's a certain way you do it, like sort of mathy-like. Let's have a calcium ion.
So calcium, that's the formula for it.
Yes.
And when we write the ion, what charge it becomes, we put the charge in the upper right-hand corner.
Now, you wrote 2, actually, let me back up. I know the charge is 2 because he's in column number 2. We talked about that earlier, right?
We did.
But you didn't write +2, you write 2 positive. What's up with that?
It works either way. I mean, some people write it +2, some people write it 2 plus. I like to see it right off the bat so that you can see what the charge is that you're going to be working with and what the number is, because we're going to work with that number a lot.
Okay, so that's a cation. The opposite was an anion. So what's an anion? An anion is something with a negative charge. An ion with a negative charge. By the way, it could also even be a group of atoms with a negative charge. So give us an example of an anion, Mr. Dimitrievich.
So let's say we do fluorine. Fluorine's in the next to last column, and if you remember last video, we said that that's a -1 charge.
-1 charge.
So we could just write minus next to it. Now notice here we don't write a 1 on either side because everyone, if you're just a minus, you're a
But it's not wrong to write -1 or 1-.
It
It makes no difference. So that's anions and cations.
And let me jump in here as well. Cations, those are your nonmetals. So if you ever on the right-hand side of the table, those are anions, which are negatively charged. So if you have anything on the staircase to that side and you're putting a positive charge, that's a big red flag. And the same thing here, everything on the left-hand side is positive charge.
Perfect. So it turns out that there's 3 rules for writing these formulas, and they are, as you can see, number 1, write the symbol of the cation with its charge in superscript. Now make sure that you write the whole rule down, right, in your notes. Number 2, write the symbol for the anion with its charge as a superscript. Is that the 1- or the 2 positive, all that stuff that Mr. Dimitrievich was saying. And lastly, you want to find the ratio of the cation to the anion with such charges so that they add up to 0. Okay, now, hopefully you've paused the video, you've written those down. Now we want to do some examples. So let's see if we can write the formula from, let's say,
Magnesium chloride.
magnesium chloride.
So you see a formula like this, magnesium chloride, and if you follow the rules here, our first thing that we need to do is we need to figure out what the charges are on and the symbols are for each one.
So the periodic table, magnesium is in column number 2, so his charge will be 2 positive. So notice he wrote the symbol and he put the charge in the upper right. This is kind of where you put squared and stuff like that, right? We're going to do the same thing with chloride, Cl, but now we're going to look, he's in the second to last column, and his charge is -1. Now here's the game, guys. You have to do some math, crazy easy math. They have to add up to 0. So I've got 2 positive and Cl negative, and so what you can do, if you think I can have as many magnesiums and as many chlorides as I want to add up to 0. Yeah.
One of the ways you can think of it is a teeter-totter. And the only thing you can do is you can either add more Mg2 pluses on this side or more Cl minuses on this side. And the end result is you have to have the charges balanced.
So I think if I were to add another, hopefully you can see this, a Cl minus to that side, +2 plus -1 plus -1 is -2. That adds up to 0. Now, when we write the actual formula, there is 1 Mg and 2 Cls. Now, it's important to note that when you write the formula, it becomes MgCl subscript 2. So he puts the 2. This means there's 2 chlorines and 1 magnesium in magnesium chloride.
And you'll note we also disappeared the charges right here.
Yeah.
They're still there.
But they
because
cancel out.
They've canceled out. We don't put a 2 plus here and a minus here.
That's right. Well, let's do another example. So what example do you want to do there, Mr.
Let's
Dimitrievich?
do aluminum oxide, and this is a kind of the peak level difficulty. So we like to show you stuff that's hard because we do hard stuff, and we also want to be able to.
So the first thing you want to do is you want to write down the symbol of aluminum, and then we got to figure out his charge. If you look at the periodic table, he's in column number 13, so he has a 3 positive charge. Oxide is just O, and it's going to have a 2 minus charge because he's in the second to last column. Now we've got to play the game where we need to add them up. We have as many as we want so that they add up to 0. And so here's an idea on how you can find this, because this is a little complex. All right, so I've got aluminum +3 and O -2. I need more negative charge to balance it out. So I write O -2. Here I've got 3 and -4. What do I need? I need more positive. So I do AL 3 positive. Now 3 plus 3 is 6. And now 2, 4, do you guys get it? O, -2. So these add up to +6, -6. And now we have 2 aluminums, 3 O's. So how do we write that?
Well, whenever we have a number of a 1, we put them as a subscript.
There's
AL2.
2 of them, AL2.
And here we have 1, 2, 3 of these, so we're going to go O3.
Bingo.
I want to point out something here that we did by accident here. See, I wrote 2 minus and he wrote -2.
Oh.
It does not matter.
Yeah.
It really doesn't matter. It's personal preference. He obviously felt more comfortable doing it that way. It works.
So can you give us an example of one of these things with the Roman numerals?
I can pick any of the ones that are in the center of the periodic table. We're going to talk about that in a minute. But let's go lead to chloride.
So lead 2 chloride. This Roman numeral is kind of weird, guys. So let's talk about what elements need Roman numerals. So like we just said, the periodic table, there are some elements that are, I like to call schizophrenic, and some that are not. Schizophrenic is like we have multiple personalities, right? So the ones that always have the same charge are the ones right here, the first column, lithium, sodium, that's called the alkali metals. The second group is the alkaline earth metals. These two are always either +1, column 1, or +2, column 2. But now, Mr. Dimitrievich, that's not true for some other, which one?
Well, this whole middle region right here, that from this, depending on the touchdown markers, but from right here all the way over to where he has the ruler, those we call the transition metals. And as a general rule, all of them in there, they tend to have more than one ion, schizophrenic, as you said.
So then you have to use Roman numerals with these guys because they might have a charge of 1, 2, 3. It changes, depends on the ion that it is.
Yeah, and there are some in here that are like, I will not be part of you. These 3 guys right here, zinc, cadmium, and silver, these 3, they're ones that actually have charges that do not change. So zinc and cadmium are a +2, and silver is a +1. We also have a couple of outliers here on this side right here, tin and lead. They are 2 of the really common ones that actually form Roman numerals, even though they're not part of this. So if we were to color all this in, we'd be like, whoop, and grab these 2 and incorporate them in there.
Yeah, so the ones that are underneath the stair step, not including aluminum, generally speaking, they have multiple charges, including the transitionary metals. And the transition metals are from 21 to 30, if you will, and then down, right?
You also can take a look here, group 3 aluminum, it's actually still under here, it's a metal, but it's not part of the transition, so it always takes a +3.
3 charge.
All right, so as you can see, this fits in that transition metal section, and that means that we have to put a Roman numeral. You cannot leave it like this, because if I just said lead chloride, you're gonna look and go, what charge does it have? And remember, the charges we have to balance off. So since they gave us a 2 in here, we love this, right?
Charge is +2.
Yeah, it tells us the charge, and what you have to remember is what is the symbol. And again, we did element quizzes on this. There's gonna be PB2+, and in honor of how Mr. Bergman does it, we're just gonna write a minus right here.
So you Cl negative, and we need to add the charges up to 0.
Right, so we have one of these 2 plus, and let's follow the same method he did.
Yeah.
We only have one of these, so if we put another one of these down below,
It's PbClCl, but we don't write PbClCl, we write
crazy talk, right? We're gonna write PB.
PbCl subscript 2. Charges disappear because they cancel out.
This is true.
Let's try one more that's real tricky.
Okay, let's try one, and I will say this, as we go through this, I'm gonna just write below with my finger. What I'm gonna say is that when you have a Roman numeral, it doesn't get all that tricky because it automatically tells you what the positive charge is. So let me do one that is kind of...
Why don't we do like 10 for phosphide?
10, what did you say?
4.
10 for phosphide. Now that's crazy.
That's odd, I know. But
10
it's not
for
terrible. No, so 10, now 10's the weird one, remember? 10 rhymes with sin, that's how you remember it. So 10 is, what's the symbol for 10?
That's S, it's
SN.
SN.
What's the charge of 10? Oh, wait for it. It's 4.
And this is why we love, now, by the way, you have to know some Roman numerals, right? But we don't have to go very high.
Yeah, up
This is
to
gonna
4, actually.
Yeah, 10, 4 plus, or +4.
Yeah.
And phosphide,
Remember, that's P.
look on the table.
Yeah, and it's in the third to the last column.
And again,
so
in honor of Mr. Bergman here, I'm gonna write it his way.
-3.
Minus
And now
3.
we need to get them to the same number. This is tricky because you got to get, honestly, a little math stuff. Do you realize you're trying to find the least common multiple? That's what you're trying to find, right?
Yeah.
The lowest
I'm
common-
Canadian, we call it the least common denominator, but either way it
It's not-
works.
No, it's multiple. Isn't it? Oh, well,
Yeah.
whatever. All right, so we need to get the ratio. So what's the ratio going to be?
So we have 4 here and 3 here. Now you can, if you're quick with math, you could probably say, well, you need 3 of these and 4 of these. If you're kind of like the person that still does some multiplication with your fingers and toes or whatever else, you might want to just do what we've been doing here and go, well, there's a 4 plus here, this is a 3 minus, can we put 1 3 minus here? But now we have 6
That's
minus.
6 and 4, so add another one
over here, and that means
That's
we have
8
8
and 6.
Then we have to
I gotta get up till I get to 12.
So now it's 8 and 9.
All right, that over here. Now that's 12, but 3 times
And bingo, we now have
3, 3, 3, 3 is 12. 4,
Negative
4,
12.
4 is 12. And now we don't say S and S and S and P, 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 P. That's weird.
That is really silly.
Really weird. P, 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 P. We write what?
SN 1 2 3
Yep.
P4. Now again, we're big fans of doing things more quickly. The reality is that if you see a 4 here and a 3 here, you can do the common denominator. If you do a common denominator of 12, you're gonna be like, wait, I need to multiply this by 3.
Yeah.
I need to multiply this by 4.
Yeah.
And that may be a quicker way if you're feeling more comfortable.
Let's
with it.
just do one more. I'm thinking it might be a little tricky for folks here. Let's leave the 10, and let's change that to oxide.
Oh, you went and did it. You went and did it.
So we still have 10, 4, so positive 4 charge. Oxide would be just O. Remember, he's in the second to last column, negative 2. And I need to add up to 0. So actually, this is easy, isn't it? You just do what? You only need one more O, and so it's SNOO, or SNO2. Folks, that's how you write the formulas from compounds. It's not that complex. We'll see you guys in class.
We'll see you in the next video.